Hello and welcome back to Ganesh Institute. In this video, we are going to talk about cyclic permutation in group theory. So what do we mean by cyclic permutation? Before that, can I give you an example? 1, 2, 2, 3, 3, 1. I'm hoping you must have watched that video where we discussed about permutations. So here is an example. Can you see that here 1 is connected by 2? And then 2 is connected by 3, and then 3 is connected by 1, which is again this bit. So can't you see that this is forming cycle, right? This is forming a cycle. So we can call it as cyclic permutation. Whenever a permutation F on the set S it is a finite set having n number of elements, okay? Let's say I'm having n number of elements, x2 up till xn. Then it should be in such a manner that if you find out fx1, it is giving you certain value. And then when you find out the value for this particular value, this is x3. Then fx3 is giving you x4. And then at last, when you will find out n minus 1, it will give you what? X1 again. If you will find out xn, last value, and then fxn, it will give you again n value. That is x1. So you'll see we start from this one and we end at this. So this is a cyclic permutation. Okay. Now, how many number of elements you are having here n? So it is of length n. For example, if I'm talking about this bit, let's say 1, 2, 3 connected by 2, 3, 1. Tell me, is it a cyclic permutation? 1 is connected by 2, 2 is connected by 3, 3 is connected by 1, and then this 1 is exactly the same. So it is forming a cycle. Okay. Now, what is the length of this cyclic permutation? It has 3 elements. And it is forming 3 different images. So the length of this cyclic permutation is 3. Okay. Tell me, what about this one? 1, 2, 3, 4, 5. And it is connected by 2, 3, 4. Let's say it is 5, 1. So can you see that it is 1 by 2, 2 with 3, 3 with 4, 4 with 5, 5 with 1. Okay, and these two are same, so it is a cycle. Every element, it's not that it is forming an identity. I mean, all the elements are different. 1 by 2, 2 by 3. There is no such element like 3 by 3, 4 by 4, right? So its length is 5. 5 different images are formed, right? So this is how you can find out. And this can be written as in this form. It can be, the cyclic permutation can be expressed as, if you see, 1 by 2, 2 by 3, 3 by 4, right? So I can write it simply as this. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 1. Okay. So it means it is in such manner. If you are given with this form, you can elaborate it in this form. Why? See, 1 by 2. 2 is connected by 3, 3 is connected by 4, 4 is connected by 5, and 5 is connected by 1, isn't it? So hence, we can represent a cyclic permutation in this manner. Hope you have got it. Now, there are certain criteria. I mean, you can find out certain questions in this form. So tell me, how can I write this cyclic permutation? 1, 2, 3, 5, 6, 4. Firstly, this is a permutation. So can I write it as 4, 5, 6? Why? I told you last time that if elements are connected by themselves only, and you don't need to write them, because if you know that the number of elements and what are the elements in the set from which permutation has to be taken, then you will see if only 3 elements are written, okay? 4, 5, 6. That means all other 3 elements are connected by themselves only. So it is self-explanatory. Now tell me, what will be the length of this permutation? And what will be the degree of this permutation? Firstly, can we say this as a cyclic permutation? 4 by 5, 5 by 6, and 6 by 4. Yes? Initially, the degree means how many elements are there which are forming permutation. So 1, 2, 3, 4, 5, 6. 6 elements are there. So degree is 6, of course. But what about length? We don't count the length of these elements which are connected by themselves only. So this is actual final value, and it has 1, 2, 3 elements. So degree is basically 3, because 3 elements are forming a cycle. Okay. Now let's say if you have changed the place. For example, if I'm having this bit 1, 2, 3, 4. Okay. What does it mean? It means 1 is connected by 2, 2 is connected by 3, 3 is connected by 4, and 4 by 1, right? It is cyclic, that's why we have written it this way. Okay. But can I change the place and see if the cycle changes or not? Okay. If I do it this manner, let's say I'm writing 2, 3, 4, 1. Okay. So 2 is connected with 3, 3 is connected with 4, 4 is connected with 1, and 1 is connected with 2. Isn't it the same thing? Yes. So that means it can also be written as 1, 2, 3, 4, or should I say 2, 3, 4, 1? Because ultimately it is also 2 is connected with 3, 3 is by 4, 4 by 1, and 1 by 2. That's the same thing. So the corollary is a cycle does not change by changing the places of the elements, but you have to change them all together. So 2 and 3 can be placed here all together. It's not that you change their images altogether. No. Okay. So this is how you can solve the problems for cyclic permutation. Whenever you have, let's say you have degree. Okay. You have a cycle of length 2. For example, this. That means it is simple that 1 is connected with 2 and 2 by 1. This is called as transposition. This cycle is known as transposition. Okay. When you have a cycle of length 2. Okay. All right. This is it for today. And we'll discuss later on certain topics, even in on permutation and all. Okay. If you like this video, then don't forget to share, like, and subscribe my channel. Till my next video, take care of yourself. Bye-bye.